This is 1120. We want just to finish 1120, then we solve 1100. But the concept is the same, especially for 1100. The paper for 1120, it was 4 of calculus. But for 1100, or for 1120, it was 4 of calculus, your exam. But for 1100, it was just normal. So for those who are doing 1120, when we start 1100, which is I think tomorrow or today, I want you to be joining. Okay? Because there are some concepts which I'm going to be explaining when I'm going to be teaching 1100. They will be very important for you actually. So, like I said last time, guys, especially for those who are on BC, remember to say they have increased the BC. The accommodation allowance, they have increased. The meal allowance, they have increased. No paying of registration. And you have been given the chance to write supplementary exams. This is the only chance you have. Once you miss it, you miss it. Okay? When you are on the PTA, guys, meaning you are going to be paying for yourself. That is what you should know. So we need to work hard. We have a lot of time. We have almost 2 weeks just to prepare for supplementary exams. For supplementary exams, they don't necessarily change the questions. The same format which came in your exam, they will just change few things. Okay? They will give you the same things, but they will just change. Question 6.2 is going to be the same question you see it here, but they will just change this equation. It's not going to be the same. But the way we solve is going to be the same. So you need to understand each topic which came in your exam. Okay? So if you can work on the 2021 paper, 2022 paper, 2023 paper, that is enough. Is that okay? And you need to build confidence that you are going to make it, you are going to do it. There is nothing hard. Just follow simple instructions. Follow each step. If you have got question, ask. So let's start. So we'll start our discussion with question 6. Find the value of ln the square root of e. So the exact value of ln the square root of e is what we want to find. How can we find this? Finding this is not hard. It's very direct actually. You guys, you know that the square root of any number is the same as x to the power half. Then I can also say, if this is true, I can also rewrite this as ln e raised to the power half. The property of log, if I have this to the power 2, it allows me to shift the power to be in front. And sometimes you can be asking yourself to say, why are we shifting this to be in front? Because in this case I have got e. I know that ln is always in base e. So ln e of e is going to give me 1. Okay? They will not give you a base for e. Just know that ln e is always in base e. So in this case, meaning the property of log allows me to shift this power to be in front. So I will say half ln e. But I'm telling you to say ln is always in base e. So ln base e of e is 1. It's the same as log base 2 of 2 is 1. Okay? Meaning that if this is 1, then I have half times 1, which is just half. I'm done. So this is the answer for that question. Okay? If you have got questions, is to ask. Part 2. Find the real values of x such that 2 minus. Yes? Yes, neither. Okay. Find The question is, find the real values of x such that 2, I will write this, 2 log base 2 of x minus 3 is equal to 1. Before I teach you this, I think let me give you the basic idea behind log. So, if I have got log base 2 of x is equal to 7, I want to change this into exponential. What do we do? You get the base raised to the power what is outside is equal to what is inside. What I mean is 2 raised to the power 7 is equal to x. Now, in this case, this is the simplest way. I can change this into exponential, but before I do that, I have to shift this 2 to the right hand side. So it's going to be negative log base 2 of x minus 3 is equal to 1 minus 2. 1 minus 2 is negative 1. I'll say negative log of 2 x minus 3 is equal to negative 1. So I have got negative both sides. Here there is negative, here there is negative. I can divide both sides by negative 1, here negative 1. I'll end up having log base 2 of x minus 3 is equal to 1. When you reach at this point now, you can convert this from log to exponential to find the value of x. So you say the base is equal to what is outside, then you say the base raised to the power of what is outside is equal to what is inside. So it will be 2 raised to the power 1 is equal to x minus 3. Now 2 to the power 1 is 2. So I'll say is 2 is equal to x minus 3. I can shift 3 to the other side. 2 plus 3 is equal to x. Therefore x is equal to 5. I'm done. There is no debate about this. Any questions so far? Any questions so far? Okay. Now, if we go to part B, saying let f of x part B is saying let f of x to be equal to this. Can you mute your mic? Mute your mic. Mute your mic. So f of x is that and g of x is that. This f of x is an exponential. G of x is a log. Okay. The first question is state the range of f of x. Now, how do you find the range? I think the range, these are the values of y. So when you want to find the range, in this case, like if you know math, even without sketching, it is very much possible for you to know the range. What does it mean? This, when we're talking about this, is exponential. Exponential, they have got what we call the horizontal asymptote. That is for exponential. Then the log, they have got what we call the vertical asymptote. That is for logs. So in this case, the number after the exponential is the horizontal asymptote. If I have got e raised to the power 3x, just like this, the horizontal asymptote is 0 because there is no number after this. But here I've got a number after this exponential, so my horizontal asymptote in this case is negative 4. Okay? So my horizontal asymptote is negative 4. After finding the horizontal asymptote, for me to find the coordinate, I need to equate the power equal to two things. To negative 3x equal to 0 and negative 3x equal to 1. The reason why I'm equating it to equal to two things, because I know that any number to the power 0 is the 1, any number to the power 1 is the number itself. Okay, now if I solve for x, we'll see that x will be equal to 0 and x will be equal to neg 1 over 3. If I'm to solve for x, for the first one and the second one. So if I'm going to have my coordinate here, this is what we're going to have. X, if x is 0, what will be the value of y? This is e to the power this times 0 minus 4. What will be the answer? In that case, we're going to get what? Negative 4, because any number to the power 0 is going to be what? What are we going to get there? Any number to the power 0 is what? You don't even know any number to the power 0?
It's the number itself, sir.
Are you sure?
1.
Any number to the power 0 is 1. Any number to the power 1 is the number itself. So here we have 1 minus 4, which is negative 3. Meaning here I have negative 3. Is that okay?
Yes.
Next, what I'm going to do is, the next thing I'm going to do is, when x is equal to negative 1 over 3, what will be the value of? So e to the power negative 3, where there is x, I'll put negative 1 over 3. Negative and negative will cancel. This will be e to the power 1 minus 4. So e to the power 1 is the same as it's going to be e to the power 1 minus 4, just like that. E is approximately 2.7 something like that. 2.7 what. So meaning e is less than 4. So we expect this to be negative side. Okay. After having this, I can now sketch. I can have my sketching here. My horizontal asymptote is at negative 4. I'll have negative 4 here. I'll put it there. The coordinate which I have is x is 0, negative 3. Where is 0, negative 3? Negative 3 in y, I can find it here. Okay, so I'm going to have that coordinate here. Next, I have half, what? Is this correct? What we are doing here? I have half, negative half in x. Okay, so I'm going to put this part here, I'm going to put negative 1 over 3. Then in x is going to be approximately negative 2 or negative 1 point something, because I'm saying e is approximately 2.7 something. So minus 4, it will be close to 1 point something, which is going to be here. So here you just put e minus 4. So I have got another coordinate which is 1 over 3, negative 1 over 3, that, which is going to be at that point. Meaning my graph is starting from this point, running away from the asymptote, going like that. The question is, what is the range? Okay? What is the range? So now, the range, these are y values. The y value is starting from negative 4, although 4 is not included, but it is running away, going all the way to positive infinity from the graph here. So I can clearly see that my range would be from negative 4 not included all the way to positive infinity. Then that will be my range. But I can also find range without even sketching. I know that here I don't have any negative here to this part here. I don't have any negative. So I only have this, meaning the range is starting from that point going to positive infinity. But in a case where I had a negative, this in front here, then it would have been from negative 4 all the way to negative infinity. Okay? So you can use either the simple method of just getting direct, or you can sketch it. Which one is okay for you?
Sir, can you just kindly repeat on the part that you talked about getting directly?
Okay. I have e raised to the power negative 3x minus 4. In front of e, there is no negative. Okay? So if there is no negative, then I'll just get the number which I have here. If it is positive or negative, from that all the way to positive infinity, that will be my range. If the number is negative in front of e, then plus a number here, you get from this number, which you are going to have all the way to negative infinity. Is that cool? Yes, it is. The next thing is to find the inverse now, f of inverse. Finding the inverse of log is not something difficult, no. So we have f of x is equal to e to the power negative 3x minus 4. To find the inverse, replace this with y. Solve for x. Y will be equal to e raised to the power negative 3x minus 4. Make x as a subject of formula, like the way we were doing under functions. So what we're going to do is I'm going to shift this guy to the left hand side. So it will be y minus plus 4 is equal to e raised to the power negative 3x. What do I do next? If I have got e, I want to drop this. I have to introduce log. But in this case I've got e, I'm going to introduce ln, because I know that ln e is going to give me always 1. So if I introduce ln, it's going to be easy for me. So what I'm going to do is I'm going to introduce ln both sides. So allow me to rewrite this as e raised to the power 3x is equal to y plus 4. Introducing ln both sides, we'll find that we have ln e raised to the power negative 3x is equal to ln, these ones will be in brackets now, y plus 4, like that. Up to this point, any problem? Okay, now here what I'm going to do is the property of logs. From the first question here, I said they're allowing us to shift the power to be in front. Therefore, I'll say negative 3x ln e is equal to ln y plus 4, like that. Next thing I'm going to do is I know that ln e is always 1. This guy will always give me 1. Wherever you see ln e is 1, then I have now negative 3x times 1 is just negative 3x, then ln y plus 4. Our goal is to make x as a subject of formula. I'll divide both sides by negative 3, both sides by negative 3. These guys will cancel. I'll have my x now to be equal to, I can divide both sides by negative, then I'll say negative ln y plus 4 divided by 3. Now after doing this, what do you do? Remember, under functions, when you make x as a subject of formula, then you replace now where there is, you say f of inverse of x will be, where there is y, you replace it with what? X. So it will be like that. Where there is y, I'll put x plus 4 divided by 3. I'm done. Any question? Okay, that is it for part B2. This was the most interesting question. When you see a function which is e raised to the power ln x like this, okay, is equal to 1. In this case, what you're going to do is this e and ln will cancel always. That's how it is. That's the law of logarithm and exponential. When these two guys cancels, then this one will just drop it. In this case, x will be equal to 1. Is that okay? So if I happen to have e raised to the power ln x minus or plus 1 like that, meaning this guy and that guy will cancel, then I'll just drop this to be x plus 1. I'm doing this for the sake of part 3. Let's go ahead and now continue with part 3. Part 3 is saying express f of g as a function of or as a polynomial in x. You know that polynomial, it is in the form of ax to the power 3 plus bx squared plus cx plus d. That is a polynomial. So we have to write this in form of now that. Let's go ahead and do it. What does f of g mean? F of g means where there is f, where there is x in the function of f, we put the whole of g. So we have got f of x to be equal to e raised to the power negative 3x. Then we have got g of x to be ln 1 over x plus 1, like that. Now f of g, meaning that where there is x in the function of f, where there is x here in the function of f, we replace the whole of g. So what I'm going to do is I'm going to say f of g is going to be e raised to the power negative, where there's x now I'm going to say it is ln, then 1 over x plus 1. I do that. But here there is minus 4. I forgot 4, sorry, here, which is 4. I have to add a 4 there. Before I continue, if you're confused already there, please ask. Okay, so let me continue. The top part here, I'm going to start playing around with the top part, where I'm going to say, according to the log, we said if I have got ln any number here, if this number is here, I can drop it to be 2 ln x. At the same time, if this number is in front here, I can drop it to be on top, then to go back to say ln 2x squared. What I mean here is this 3, I'm going to drop it to be on top. Okay? So what I'm going to do is I'm going to say e raised to the power ln, then I'll say 1 over x plus 1, then to the power negative 3 minus 4. Next, what I'm going to do now is f of g will be equal to, I mentioned to you to say e raised to the power ln, these two, they are going to be cancelled. You just drop this, meaning I have 1 over x plus 1, everything raised to the power negative 3 minus 4. That's what I said. Next, what I'm going to do is I can make 1 over x plus 1 to be the same as x plus 1 to the power negative 1, meaning the The one on top has disappeared. I know you know that. If you have x to the power y, this is the same as x times y to the power negative 1. If I have 2 right divided by, or let me say 1 divided by um, x to the power 2, this is the same as x to the power negative 2, meaning I've removed the fraction. Okay, so that's what I'm going to do now. What I'm going to do here, guys, is I'll get rid of this part here. So I'll say f of g is going to be x plus 1 raised to the power negative 1 times negative 3. Negative 1 is for me to remove this fraction, then negative 3 is the one which I have here, minus 4. So f of g will be equal to negative and negative will cancel, x plus 1, everything raised to the power 3 minus 4. Now, they want us to put this answer, if they just said express f of g, or maybe find f of g, would have ended here. But the question is, express f of g as a polynomial in x. So we have to start now expanding this. Okay? So expanding this, we are going first to start x plus 1 to the power 2, then x plus 1. So we expand first this. Expanding this is going to be 2 times x is x squared, x times 1 is x, 1 times x is x, then 1 times 1 is 1. Then I also have x plus 1. I can simplify this and say x squared plus 2x plus 1. Then I have x plus 1. Now I can also expand this again. So x times x is going, x times x squared is x to the power 3. X times 2x is going to be 2x squared. X times 1 is just x. 1 times everything inside, I will have x squared 2x plus 1, like that. But remember, this I'm going to replace it here, so that I've expanded everything here to this one. So I'll just replace it here to say, but I can simplify it further and say the right terms can be added. So I have x to the power 3. This and that can be added to 3x squared. This and that can be added to 3x plus 1. So this is what I'm going to replace with that. So I'll say x to the power 3 plus 3x to the power 2 plus 3x plus 1 minus 4. I can continue and say my f of g in form of polynomial, it is x to the power 3 plus 3x squared plus 3x 1 minus 4 negative 3. This is my answer in form of polynomial. This question had 4 marks. That is it for part A and B, unless you have questions before we go to C. Yes, Niza.
I looked out. I was kicked out for when you were doing question 6A1. Just wanted you to repeat something.
So you wanted me to repeat what?
6A1.
6A1. Only 6A1?
Yes, sir.
So 6A1 6A1 we said it is ln of e. If I have got the square root of x, it is the same as x to the power negative half. Therefore, ln can be written as e to the power half, meaning I've removed the square root. The property of log allows us to shift the power to be in front. Therefore, this will be half ln e. Ln is always in base e. So ln e of base e is 1. So it will be half times 1 is just half. Have you seen, sir?
Yes, sir.
Okay. So let's go to part C. Show that the function f of x, x minus ln x, for x is greater than 0, is increasing on the interval 1, comma, infinity. You have been told already that this function is increasing at an interval of 1, comma, infinity. Show 4 marks. How do you show this? To to know where the function is increasing or decreasing, you have first to differentiate the function, equate it equal to 0, solve for x, find the critical values. Okay, those values we are going to put them on the table, then we do it the normal way, like the way we do it always. Before we do this question, let me just give you the basic idea behind logs. If I have ln of a, if I want to differentiate this, it is the derivative of a divided by a. I differentiate the one I have divided by the original, the one I have. If I have ln of 2x squared, okay, to differentiate this, I'll say the derivative of this is 4x divided by the original, which is 2x squared. I've explained that. Let's differentiate what we have. F prime of x will be equal to the derivative of x is 1. The derivative of ln x is the derivative of x, which is 1, divided by the original x. Equate this equal to 0, solve for x. So I'll say 1 minus 1 over x is equal to 0. Divide here by 1, I'll have x, the common denominator. 1 into x is x. 1 times that one, we're going to have what? We're going to have x minus x into x is 1. 1 times 1 is 1. Now I have x minus 1 divided by x to be equal to 0. I want to find the values of x. What are we going to do? I want to find the values of x. What are we going to do? Hello? I want to find the values of x. But initially, remember, after reaching at this point, we have been told that the x value should be greater than 0. The best way to deal with this question is when you reach at this point, because you are going to equate it equal to 0, which we don't want. We have been told that x should be greater than 0. When you reach at this point, you have now to say x minus 1 divided by x greater than 0, because x can only be greater than 0. Now we solve for x. Okay? So if I solve for x, we know that this now is inequality. So I'll say the numerator is going to be x minus 1 greater than what? 0. So x will be greater than 1. I leave it there. Next, I'm going to get the denominator. X will be greater than what? 0. Now I have got two critical points. The reason why I can't cross multiply here is we are saying this is equal to 0, but the condition is that x has to be greater than 0. If you want, you can even from here you can just equate this greater than 0. It's okay. But if you want, you can put that equal to 0. But when you reach at this point, put greater than 0 because the condition is that x has to be greater than 0. Is that cool? So if x is greater than 0, meaning our critical point is that x should be equal to 0 and x is 1. Okay? These are just critical points. I'm going to put them here. Let me just do this. Let me write. I'll say critical values. Okay? The critical values x is equal to 0 and x is equal to 1. After doing this, I can now go back and put my table and see where this function is going to be increasing. So what I'm going to do now here is the first critical point I've been given is 0. I'll put it here 1. I need to put a number greater than this is 2. I put it there. Here I can put negative. I can put half, which is 0.5. I'm not going to put any number here. The reason is the condition we have been told that x should be greater than 0. Once I put a number here, meaning that number is not greater than 0. Therefore, this row I'm not going to put anything. I'll leave it. I'm not going to play around with that row because I don't have, the condition is telling that x has to be greater than 0. So I can't work out with that one. Once I put negative 1 here, then I'm not following the condition. So this one, I'll leave it. Okay. Now, I had the x minus 1 and x down. So what I'm going to do, I'll say x minus 1, then here just x, then here I'll say x minus 1 divided by x, like that. Okay. So we start now plugging in the values. If I put half here, am I going to get positive or negative? It's going to be negative. If I put half there, positive. Overall, negative. If I put 2 here, positive. 2 there, positive. Overall, positive. The question is, show that the increasing in this function is increasing at an interval of 1 comma positive infinity. And for sure, I can clearly see that increasing, we are getting the part of positive. Okay? If it is negative, then it is decreasing at that point. Is that cool? So I'm going to get this part. So this part is starting from 1 all the way to positive infinity. So from the table here, I can see that it is increasing at the interval 1 comma positive infinity, hence shown. If you don't want to use this, you can use the number line. Okay? How are you going to use the number line? This is what you're going to do. This happened to be our number line. We have our critical values, negative infinity, positive infinity here. So I'm going to put here to be 0, here to be what? 1. A number here I'll put 2. A number here I'll put negative, or I'll put half, not negative half, but half. The condition is telling us that x has to be greater than 0. I can't put any number less than 0 here. It's not possible. I start now. I have x minus 1 divided by what? X, like that. So if I put half here, am I going to get positive? On top here, if I put half, it's going to be what? It's going to be negative. Down here is going to be positive. Negative divided by positive is negative. If I put 2 on top, positive, down, positive, overall positive. So it is increasing at an interval from this point 1 all the way to positive infinity. So you say it is increasing at 1 comma infinity, hence shown. Any question there? Okay, so let's do the last one. The last one is integration. This question, I can solve this question using integration by part. Why am I going to use integration by part? Anyone who can explain to us why are we going to use this to integrate this by using integration by part? Okay. So here I'm going to use integration by part. Integration by u substitution, it can't work out because integration by u substitution, we have to replace u, then x has to be cancelled out, and in this case x cannot be cancelled out. Cannot be cancelled out because x, 1x is not squared, so I can't use integration by u substitution. I can't use integration by partial fraction because this is not a partial fraction. Then the only thing I have remained with is integration by part. Integration by part, there is a formula which you need to understand. Okay, so the formula for integration by part is the integral of v du is given by uv minus the integral of v du, like that. So initially, for you to know that this is my u, we use what we call yard. L is log, I is the inverse function, A is algebra, T is the trig, E is the exponential. So you make u the one which comes first in this. So we have x is algebra, e to the power x is exponential. Which one are we going to make u? Which one are we going to make to be u? Why x? X because it's algebra. Are we in support with her answer? So initially, let me just do this. When we are the formula here, I'm supposed to, I've forgotten one thing. It's the same thing, but I'm supposed to start with u dv. So it is u dv, that is the formula, is equal to uv minus, then here you do the opposite, it's v du, like that. So this is the formula for integration by part. So using Riate, I can clearly see that my u will be x. Okay, so my u will be x. Then what will be my du? If I differentiate this one, if I differentiate x is what? It's 1, right? So 1, I'll say 1 times dx. Okay, I'll say 1 times dx. So in this case, it's just dx. When you are differentiating, even using u substitution, we say when you differentiate it, then you do times dx. Why? Because we have dx here is the one we're going to be replacing with. The remaining part will be v. In this case, our v now is x, is e to the power, is e raised to the power x. Now we need to find dv. Now in this case, dv we are not differentiating, it's different. When you have e, we are differentiating e, but when we are talking about v, we are going to say we start with dv. So the remaining part is going to be dv. Okay, so I'll say dv is going to be e raised to the power x dx. So I have to integrate this. Okay, so when I integrate e, okay, let me give you this. What is the derivative of 2x dx? What is the derivative of 2x dx? Hello. What is, okay, what is the integral of 2x dx? Guys, you don't know integration? Okay. So the integral of e of x is just e to the x. In this case, let me give you basic idea using this. If I have e to the power 2x dx, the integral of this is, what we normally do is we get the same thing, e raised to the power 2x divided by the coefficient which you have. So divided by 2, then plus c. So in a case of e like this, meaning this is going to be e raised to the power x, the coefficient is 1 divided by 1, which is going to be the same as just e to the power x. So this e to the power x will not change. The v and v will be the same. Then I'm going to say my v now is e to the power x. So now we use this formula now to plug in the values. So we'll say we want to find x e to the power x dx will be equal to, my u is x, my v is e to the power x, minus the integral of v is e to the power x du is also what? My du is just dx, like that. Any question? Questions are welcome. At this point now, I'll just continue and say my x e to the power x dx will be equal to, I just copy this, x to the power this minus the integral of this will not change, it's just e to the power x. Now I need to add a constant, so this is my answer in that case. This question had 4 marks as well. Any question? That's the end of question 6.